we've already run the parametric, so I can show you the parametric results. In the final parametrics table, it shows you exactly what happened, how the core was displaced, and it gives you a table of all the force measurements. And we can look at the animation of the field line plots. That'll open up in a Windows Media Player window. And as you can see, the core moves through all of its positions. And now we'll take a look at the force that was produced on the core at each of the 11 steps. And that's displayed in an autograph window. And I'll just change the axis here. So at the initial step, where the gap was maximum, you have about 14, or I should say 140 newtons of force on the core. And then as the plunger core moves down towards the stop, the force dramatically increases until the final force is about 5 times as great. It's 711 newtons. So this would be a conventional parametric, which most users are familiar with. It's equivalent to running a model through a performance test over its range of motion. Now, something else you would want to use parametrics for is to create a number of different prototypes. So, for example, perhaps you wanted to see what would happen as you made the diameter of the core greater. So we've in fact done that in another parametric. And if we look at this parametric, what's happening here is that the highlighted regions and segments, they're part of a size parametric, and these are displaced in the x direction so that it effectively doubles the radius or the diameter of the moving core over a series of 5 steps. So we'll just do a parameter validate so you can see that happening. Now, again, this is like the first parametric. It's just a single parameter, single loop. But it would be nice to combine both features, the parametric that produces a number of size prototypes, but also for every size you'd like to run the model through its full range of motion. So if you added an extra loop, you could accomplish both things in the same parametric study. You'd have an outer loop that creates prototypes of different sizes, and an inner loop that runs each prototype through its performance variations. So we can easily do that. I'm going to add a second loop and a second parameter, which is identical to the earlier model that I just showed you.